All right, so I'm going to keep going here talking about some of the last couple of elements that we need to understand in order to draw and analyze these circuits. So up to this point, I've drawn some wires. I drew wires here. I highlighted them in yellow. Um, we've been drawing circuits with wires, or let's see, where else have I? Yeah, I've been using wires kind of nonchalantly without introducing them. I think it's just assumed that I'm drawing wires here, but there are some important properties of wires in these circuits that we're going to be solving that I need to address. So if I were to just draw a voltage source like this, and then a resistor here and a resistor here, the resistor and the voltage source, they have their own legs or their own leads connected to them, right? Those are also wire practically in real life, but for the sake of our circuit, those are just the elements themselves, and I haven't even connected them yet, and I need to connect them with some wire. So I would draw a wire here, a wire there, a wire here, and a wire here, and then I would have a complete circuit. But it's important to note that when we solve these circuits, we need to assume that this wire itself is infinitely conductive, or basically its resistance is zero. And so practically what that means, or for us what that means, if you remember, I drew a resistor. Or I was talking about resistance previously, where I talked about how the area of this element, the length of the element, and the resistivity of the material are the three things that determine our resistance, right? So the equation for resistance is resistivity times length divided by the area, okay? Well, for the wires that we're going to be looking at in these circuits, and specifically in DC circuits, in this class, this is an introductory class, we're going to assume that the resistance of all of our wires is equal to zero, okay? So, of course, the resistors are going to have some resistance, and I'm going to label that resistance when we give you, a resistor. It's going to be labeled with some resistance, but we're going to assume that the resistance in all of our wires connecting the components of our circuits is zero. And so, like I said, we're basically going to assume that the wires are infinitely conductive. Okay, so resistivity, rho, which I have written here, resistivity and conductivity are inverses of one another. So if I assume that my wire is infinitely conductive, right, its conductance is infinite, that means its resistivity is zero. So from there, the resistance of my wires goes to zero, okay? And so there might be some associated length, if you wish, and some associated area with that wire. Maybe it's a 24 gauge wire, maybe it's a 30 gauge wire. Doesn't matter. We're going to assume that the resistivity is zero, and so all of the wires basically present a zero ohm resistance. And of course, that's a pretty good approximation. Most wires that we use to connect circuits together are made of copper. The conductivity is very high, the resistivity is very low, and so the 0 ohm assumption is a good one. That assumption is valid for this class, and that's the assumption that we're going to make when we solve these circuits. Okay, so from this point forward, all you have to know is that the wires connecting the elements together are ideal wires, and they do not have any resistance, okay? We also want to talk about ground real quick. So I want to talk about the symbols I've seen for ground. This is one of the more common ones. This is the one LT Spice uses. I've also seen this one a lot, and then even more recently, I've seen this one a couple of times, which is an interesting one. Mainly, I'll probably bounce between these two, but I'll focus more on this one because LT Spice uses this one right here. And so the question is, what does ground tell us? For all intents and purposes for this class, we're just going to focus on one aspect of what ground tells us. There are all kinds of grounding techniques and grounding strategies for safety, and circuits that you use have different types of grounds. If you're working with mixed signal circuits, they have analog and digital grounds. It gets very complicated. I have an entire 1,300 page book somewhere in my Google Drive all about ground, which is, so it proves that there's an exhaustive topic just on grounding alone. Okay, but for this class, it's good enough to just note that what ground tells us is that node or net where I see the ground symbol has a potential of 0 volts. Okay, and so basically if I'm looking at a circuit and I see that ground symbol, I know that net is 0 volts. So if I were to have my circuit just like this, let's say that this was a 5-volt source, 5-volt battery. Basically, I'm saying that the minus terminal of my battery is at 0 volts. That means that the plus terminal of my battery would be at 5 volts. And this is important because, right, if I know Ohm's law, and I'm looking at the current flowing through my resistor here, it's going to be the voltage across the resistor, or 5 volts minus 0 volts over R. That could be the case. The same current could flow in a circuit that has a resistance of R again, but this is 105 volts and this is 100 volts, and I would never know what these voltages are unless I had a ground symbol, because that ground symbol tells me that this bottom voltage is 0 volts. Okay, if I don't have a ground symbol there, I can't possibly, all I know is that this terminal is 5 volts higher than this terminal. There's an infinite number of solutions there, right? So it's going to be important moving forward as we solve circuits to note that the node where I attach this ground symbol is the node where the voltage is 0, okay? So keep that in mind as we move forward. And typically where you're going to start when you solve a circuit, once you have all your equations, is you're going to have to note where is my ground symbol, and from there I basically have a known node voltage, and from there I can solve for the rest of my node voltages once I have my currents and whatever. We haven't talked about a lot of that stuff yet, so just for the time being, keep in mind that the ground symbol denotes the net that has 0 volt potential. And I'm going to go ahead and end this video, and in the next video I'm going to talk more specifically about junctions and nodes.